You're just given the basic equation, and it's up to you to manipulate a particular equation to solve the other quantity. So again, my example was speed. Speed is given as distance over time. You're given that, but in some cases, you'll be given the velocity or the speed and the distance, and then you solve for the time. So again, you need to manipulate the equation given to you to solve for the time. So again, this is an important skill that you need to have, and combining equations to find different values. So the basic rule is to move something to the other side of an equation. Do the opposite math operations. Well, you've done this one in your, maybe in solving equations in your math, okay? So what you do on one side, you also do that one on the other side. The meaning of this one is that if you're adding on one side, you also need to add to the other side. If you're dividing in one side of the equation, you also do that one on the other side. So the meaning of this one are just the sides of the equation, okay? So the different side of your equation. You know that you have the right-hand side of the equation and the left-hand side of your equation. So let's take these examples here. You're given, well, this is the formula for speed, distance over time, but you need to solve for t. So the meaning of this one is that you just express from the given equation, you're going to express them in terms of, well, that means that you're going to separate the variable t from the other symbols, okay? So therefore, instead of v on one side, you need to have only t in one side of the equation. It doesn't matter if that particular variable is in the left-hand side or in the right-hand side. Although, conventionally, the one that we are solving should be placed in the left-hand side. So that means that since we are solving for t, t must be placed on the left-hand side. That is by convention. But again, as I mentioned, as long as that you have separated your t with v and d, again, that's good enough. So in solving for the value of t, how would I separate that one? Well, you have v is equal to d over t. If you can remember in your math, you're being taught that if the variable is at the bottom, you need to get rid of that one. Anything that is in the denominator, it's much better to deal it if it is in the numerator. So in this case, the right-hand side is in fraction form, d over t, but any, if you can remember, any whole number could be represented as a fraction if you're gonna try to place 1 on the bottom. So v over 1 is just the same thing as v. That is just to show explicitly that, yeah, the one side can be expressed in fraction form, the other side is also fraction form. I want to get rid of my t. So that means that t should be taken from the bottom. So what I'm going to do is I'm going to multiply it by t. So multiplying it by t, remember, I can cancel out this variable here. But remember that canceling out doesn't mean that it's gone. The value there is equal to 1, because it follows that any number divided by the same number will give you 1. But if you can see in our basic rule, whatever you do in one side, you do that one on the other side. So I'm multiplying on the right-hand side of my equation. So I will also multiply this one on the other side. So if I'm going to do that, t is canceled here. That means that the value of that one becomes 1. And the left-hand side of my equation becomes t times v will give me tv. It's equal to d. But then again, I want to separate my t because I'm solving for t. So that means that I need to get rid of v on the left-hand side of my equation. So to do that, I need to divide this by v, because v over v gives me 1. Again, this just gives me 1, this whole thing. Canceling means that, again, the answer is 1. But since I'm dividing on my left-hand side, follow the basic rule, I will also divide the other side. So doing so, v over v will give me 1. So therefore, that leaves me with t. So t, therefore, is equal to d over v. And that would be your final answer. This is now from your speed equation, you get the value of your expression for t. Okay. So let's move on to the second one. Again, this is an equation for maybe uniform motion. D is equal to 1/2 at squared. This is still a kinematic equation. Okay. But I need to solve for t. So same thing. Again, if I will encounter something with a fraction, I need to get rid of that one first. So I have over 2. Remember that this is just the same thing as 8t squared over 2. So if I want to get rid of 2 in the right-hand side, again, just to simplify my equation, I know that I want to separate my t because I'm solving for t. So I'll be multiplying both sides by 2 because doing that gives me 2 over 2 is equal to 1. So in the sense, 2 is gone on the right-hand side of the equation. So this gives me 2d. It's a t squared. A t squared. Again, I'm solving for t. So that means that I'm going to separate my t. Remember, I'm solving for t, not t squared, okay? But just t. T to the exponent of 1, not t to the exponent of 2. However, I still have a in the side of my t. Again, general rule is that I need to separate that one. So to get rid of a here, I will divide it by a because a over a gives me just 1. So canceling doesn't mean that it is equal to 0, but the answer is 1 because any value divided by the same value will give you 1, not 0, okay? And this is over a because, as I mentioned earlier, whatever you do on one side, do it on the other side also. So this gives you 2d over a is equal to t squared. But then again, you're solving for just t, not t squared. But I think you've encountered this one in your either Math 8 or Math 9. So to get rid of my square there, I just need to take the square root because the square root of t squared will give me t. But since I'm doing the square root of one side, do it also on the other side. But remember this one here. Remember that this is 2d over a. So if you're doing the square root thing, make sure that you include the denominator here. Okay? So, okay. So now I can have t is equal to square root of 2d over a. So again, it doesn't matter if it is the right hand side or in the left hand side, as long as it is on one side, okay, on one side of the equation. So therefore, t is equivalent to the square root of 2d over a. Because anyway, this is just, again, if you want to write this one conventionally, that is just equivalent to this one. So you can just interchange the two. Gives you the same thing, okay? Although, again, conventionally, you write your the one that you're solving in the left-hand side. And for the last one, we have here solving for d. This is another kinematic equation. This is an equation for objects moving with constant acceleration, okay? But we need to solve for d. So I'm just going to write it again. Vf squared is equal to Vi squared plus 2at. So again, the first thing that I'm going to do is try to separate everything, both the variable and the constant, from my d. In this particular case, 2 and a here is multiplied to d. But I have a plus sign between that term with Vi squared. So if you have this particular case, make sure that you start with separating the Vi squared in this case, the other term, if you have more than one term. So to get rid of my Vi squared here, I need to subtract this with Vi squared because Vi squared minus Vi squared gives me 0. But remember, again, the general rule is that whatever you do on one side, you also do it in the other side. So you have minus Vi squared. So if I'm going to write this one, remember that I cannot subtract the 2 because they're of the different variable. This is the same thing as x minus y. X minus y gives you x minus y. You cannot combine the two because they're dissimilar terms. Same thing with this one. Vf is a different variable with your Vi. Well, actually, this pertains to final velocity and your initial velocity. So therefore, you cannot combine the two. So just you write them as Vf squared minus Vi squared. And then this is now equal to 2ad. So now, again, I should always start with a different term. Now I get rid of my Vi squared. I need to get rid of my 2a because, again, I only want the value of d. Again, I'm solving for d. So to get rid of 2a here, I'll just divide this one by 2a. Again, why would I do that? Because I want to cancel them, or I need to get a value of just 1d. The coefficient of d should be equal to 1. Remember that for a term without any coefficient, automatically the coefficient there is 1. So I'm dividing both sides. I divide one side with 2a. I will also do that on the other side, 2a. So now I'll get d is equal to vf squared minus vi squared all over 2a. And that should be my final answer. Or doing the conventional thing, d, or the d should be in the left hand side. Again, it's just the same thing over 2a.